Welcome back to Daily Dose of Space. When we look at the universe, it feels ancient, quiet, and almost timeless. Galaxies stretch across billions of light years. Stars are born, live, and die on scales that dwarf human history. And yet, here we are, a young species on a small planet, asking questions about the entire cosmos. But there is one question that rarely gets asked. Not where we are in space, but when we are in the universe. Are humans early? Arriving near the beginning? Before the universe truly wakes up? Or are we late, appearing after the best opportunities have already passed? Tonight, we're going to explore the idea that timing may be just as important as location, and that our place in cosmic history might quietly determine how far humanity can ever go. The universe has a timeline. It's easy to think of the universe as static, as if the stars we see tonight have always been there and always will be. But the universe has a history. It began almost 14 billion years ago in a state far hotter and denser than anything we can imagine. In its earliest moments, there were no stars, no planets, no atoms complex enough to build life, just expanding energy and simple particles cooling over time. The first stars took hundreds of millions of years to form. They were massive, short-lived, and violent. When they died, they seeded the universe with heavier elements, the raw materials needed for planets, chemistry, and eventually biology. In a very real sense, life required the universe to age. Too early, and there are no planets. Too late, and the stars begin to fade. This already tells us something important. Life like ours can only exist within a narrow window of cosmic time, and that window may be much smaller than we assume. When our sun formed about 4.6 billion years ago, the universe was already more than 9 billion years old. Enough time had passed for multiple generations of stars to live and die, enriching the galaxy with the elements that make Earth possible. This suggests that intelligent life cannot appear at the beginning of the universe. But does that mean we're early? Or does it mean we barely made it in time? The Golden Age of Stars. Stars are the engines of complexity in the universe. Without them, there are no planets, no chemistry, and no energy gradients to support life. But stars are not eternal. The universe produces stars at a changing rate. In fact, star formation peaked billions of years ago. The cosmic star formation rate reached its maximum roughly 10 billion years in the past and has been declining ever since. In simple terms, the universe was more active long before humans existed. More stars were forming. More massive stars were exploding. More energy was available to shape complex environments. This raises a disturbing possibility. What if the best era for life and expansion has already passed? Many of the most massive, energetic stars that could power advanced civilizations no longer exist. Over time, galaxies slowly run out of star-forming material. Gas gets locked into long-lived stars or scattered into intergalactic space. The future universe is quieter. Red dwarf stars, small and dim, will dominate the cosmos for trillions of years. They burn slowly and live incredibly long lives. On paper, this sounds ideal for life. But red dwarfs are also volatile. They produce intense stellar flares, powerful radiation bursts that can strip atmospheres from nearby planets and sterilize their surfaces. So even the stars of the future come with serious challenges. If intelligent civilizations require a balance of stability and energy, then the universe may only offer that balance for a limited time, which leads to an unsettling thought. What if we are not early, but already late to the party? Technology, energy, and cosmic opportunity. Timing doesn't just affect stars. It affects what civilizations can do with them. Advanced technology requires energy, massive amounts of it. Every serious proposal for interstellar travel, megastructures, or large-scale computation assumes access to stellar-scale power. But as the universe expands, galaxies move away from each other. Distant galaxies are already receding faster than light due to the expansion of space itself. Not because they're moving through space, but because space between us is stretching. This creates a cosmic horizon. Beyond a certain distance, regions of the universe are permanently unreachable. No signal, no spacecraft, no future technology can ever reach them. And that horizon is growing smaller. Every year, more galaxies slip beyond our reach forever. A civilization that arose billions of years earlier would have had access to a denser, more compact universe, more reachable galaxies, more available resources, more time to expand before cosmic acceleration isolated everything. A civilization that arises much later may find itself trapped in a cold, empty universe, with only its local group of stars remaining visible. This suggests something uncomfortable. Cosmic expansion may punish civilizations that appear too late. And if advanced life requires long periods of evolution, perhaps intelligence is always delayed, arriving after the universe has already begun to close its doors. If that's true, then even the most advanced species may never explore more than a tiny fraction of what they can see. The silence of the cosmic timeline. This idea connects to one of the biggest mysteries in science. If the universe is so vast and so old, where is everyone? The traditional answers to the Fermi paradox often focus on distance, technology, or self-destruction. But timing may be just as important. Civilizations may be separated not just by space, but by epochs. One civilization might rise and fall millions of years before another even invents language. Signals fade, artifacts decay. Entire histories vanish long before another intelligence looks up at the stars. Even if two civilizations exist in the same galaxy, their windows of detectability may never overlap. The universe doesn't need to be empty. It only needs to be out of sync. And if intelligence is rare and slow to develop, then the universe could be full of isolated moments of awareness, scattered across billions of years, never meeting, never knowing about each other. This reframes the silence of space, not as evidence of loneliness, but as evidence of timing. Are we exactly where we need to be? So where does that leave us? Humans exist at a time when stars still shine, galaxies are visible, and energy is abundant enough to build technology. We are early enough to see the cosmic web, but late enough to be built from heavy elements. In that sense, we may be perfectly placed. But perfect does not mean unlimited. The window for cosmic expansion may be narrow. The universe may allow intelligence to arise, but not to dominate. To observe, but not to conquer. Perhaps that is the balance. We are here to understand the universe, not to fill it. The stars may not be stepping stones, but chapters in a story we are briefly allowed to read. And maybe the most remarkable thing isn't that we haven't gone farther yet. Maybe it's that we exist at all, at this precise moment in cosmic history, able to ask these questions before the universe slowly fades into darkness.